Okay, so as I was starting to mention, so I guess I'll let me step back for a second. Welcome to week 12 of our new reality here. I hope that everybody's doing well. I'm doing well. Yes, kids are driving me nuts, as I said before, but I'm surviving so far. As I said before, if you see me rushing away, it's because I'm trying to break them apart so they don't kill each other. So it may happen. It has happened before already. Not with you, but it has happened before. Anyway, what we're going to be doing this week, today, we're going to be talking a little bit about the exercises. I started to mention about 11, 12, 13. I'm not going to go through 11 nor 12, but I will be showing a high-level detailed view of exercise 13, which is the one about the prime ministers. I'll have it running in a second and you're gonna remember which one is that. The test will have a Windows application, so it's very important that you practice Windows application development, how to create a project, how to add components, how to add controls, how to name them properly. Very important that is how you're gonna get ready for the final exam, okay? But you're gonna be doing some of that today during exercise time. So our first part here, we will be reviewing exercise 13. Our second and third hours will be around lecture and demonstration of test-driven development. That's the main topic of this week. And then in our last hour, we're gonna wrap things up with an exercise. So exercise demonstration of exercise 13, theory and demonstration of test-driven development, and last hour we're gonna be doing exercise. During exercise time, if anyone has questions about the assignment or anything like that, I can give you a hint, I can help you out 101, okay? Before I get going, any questions in general, in particular, anything? I will keep Padlet open as usual. Anything that might be in your minds to ask me. Quick note here, if any one of you lose connection, audio, during the class, one of two things. Might be my problem, and then please alert me for that, because then I have to fix my mic here, my environment, or it might be yours. If it's a problem with your setup, because I'll be asking the other students if they are having the same problem. If they are not, the problem most likely it's in your setup. So you may want to close GoToMeeting, come back to GoToMeeting. Worst case scenario, reboot your computer there, okay? That has happened in other sections, and because I cannot talk to the person anymore, because the person cannot hear me, so I'll let you know that already up front. Sometimes you lose audio, so disconnect from GoToMeeting, connect again. Hopefully that will work out for you. Okay, so as I mentioned, we're gonna be starting by talking about exercise. Under contents, about exercise 13. Exercise 13 is the one under week 11. This is the one about the prime ministers. I will open Visual Studio here and I will walk you through the codes. Okay. Okay, so this is what we have for the exercise 13. I'm just gonna quickly have a look at that. You have been provided with Prime Minister's class. Okay, so here's the Prime Minister class. It has first name, last name, term, and party. Once you run this application, once you build it, it's gonna look like this, where you have the list of last names of prime ministers on the right hand side. You can click the prime minister and then it loads the picture, name, term, and party of that particular prime minister that is selected. Okay, so that's what we're gonna be putting together. Now, I have the solution already done here, so I'm not gonna go and add everything manually anymore. This code, if it's not provided yet, it will be provided. I think the code is already there. So I just want to explain that. So you have been given the Prime Minister class. We have a very simple class here with 4 properties and 4 fields. No constructors, nothing else here. Very simple one. Then we have this interface, this form. Okay, I have renamed the form. It's now called FRM Prime Ministers. And then we have a few controls in this form. First one here is the control that displays the picture. Okay, so we have a picture box, which I've called pick photo. Okay, so that's the control that will show the picture. Then we have a few labels. Okay, we have the label with the name. So I've called this label LBL name. Then we have the static label term. Okay, this does not change. It just has the name term there. So I did not bother to change the name of this label because we will not be using this label in the code. So I left as is. I did the same thing with the party label. This is the party. This is a static label. It doesn't change over the course of the application, okay? However, the ones in front of them, they do change. This is where the dynamic term gets loaded. Then I put a proper name, LBL term. Then we have, guess what? LBL party, okay? So these 3 labels, I've placed names properly. Static label, okay, static means that they don't change. The text in that label does not change. We don't need to worry about referring to that label in the code because it's just from a static point of view. We don't need to call that control, that widget in the code because it's just static. Okay, perfect. Now we need to change the name, the term, and the party. So we put proper names to them, okay? We also put correct name here to the list box. We have a list box called Prime Ministers, okay? This list box will store and list the last name of each one of the 5 last Prime Ministers, including the current one. Okay, so let's have a look at the exercise again. So we have the class, we have the UI that we need to reproduce. Actually, we have the names here that we need to put for this, for the different controls. Look, we need to create on step 4. We need to declare and create a list. Remember, we have seen how to deal with lists in the last class, last week. Okay, so you're gonna be using a list here to store the list of prime ministers. Okay, so we have declared this one as a private field in our form. Where do we do that? Well, let's go here to Visual Studio. Let's right click and let's go to view code. View the code behind this form. Okay, so let's view the code. Look, at the very top, look what we have. Private. We are used to have private fields. Remember, in our simple Prime Minister class, we have private fields here. Okay. Now here, this private field member is not very simple. I mean, it's not a string, it's not a number, it's a list of prime ministers. Okay, so we declare as private, we say prime ministers equals to new list of prime ministers, and then we create it. So when we load the class, we have a list of prime ministers, but this list at this point in time, it's empty. Okay, so we need to add the names of the prime ministers in that list. Let's see who can recall that. I need to load the list of prime ministers in this box here, in this list box. I just need to load that once, okay? Just once. See, when I run the application. Okay, so as I was saying, I was asking a quick question. Which event should we use to load the list of prime ministers in this list box? Which event should we use for that? Any guess? Anyone? Yes, the loads. That's correct. Yes, Ederson Sina, that's the loads. The loads of which control? Where is this load? Where can I find that? Is it a load of the box, of the list, of the labels? Correct, Sina. It's the load of the window, the load of this form, okay? So I'm gonna click the form, I'm gonna go to the events, to the light bolt, and because it's already created, I can see that the load has already a method, an event assigned to it. So I'm just gonna double click there. We flip back to the codes. And Sina, just to answer you the question, a partial class is a class that is partially located in this file and partially located in a separate file. I mentioned about that when I said that we can use partial classes to split the same class code in two different files. This one here, this partial class, we control this one. However, Visual Studio is the one that controls the other file, which is the other part of the class, which is this one here. So look, we have the other part of the partial class of the form prime minister partial class. So it's partially here, it's partially here. When it gets compiled, those partial classes, they get combined into one single class. And this is usually used by a tool like Visual Studio. So it can say, I control this partial class here, but you as a developer control this one here. In the end, the compiler put both of them together. Does that make sense, Sina? Okay. So let's go back here to our load event. So look what I'm doing here. In my load event, I'm adding manually. I get it, it's manually, but that's fine because we want to focus here on the use of a list and how to populate that to the interface. Okay, so we are calling the add method of our prime minister's list, and we are giving to that method a new prime minister. Okay, we are giving a brand new prime minister. We are actually calling the constructor here. Look. But I assume that you can see that there is something different about this. There's something a little bit different that we have not seen before. We are not only creating a new object here, but we are using the curly braces here to automatically set the properties, the public properties of a prime minister. We are setting the first name, the last name, the term, and the pi. So at the time that we are creating the prime minister, we are setting all properties of that object as well at the same time with this different new strange syntax using curly braces right after the constructor call. Okay? To be honest, this is the same thing as we'll do. I'm gonna give you the equivalent. We could have done this. Prime Minister PM equals to, I'm gonna say, new Prime Minister. And then I can say PM dot first name equals to Justin. And then last name Trudeau. And then we keep going like this. And then we could add to the list like this. We could say add PM. Okay, so again, just to finalize here, we could say term as well. Term is this one. I'll add the question in a second. So and then we have party. Okay, so I could have done this, and then I would have added. So the lines that are selected, this has the same effect as this one here. Let me have a look at the message. So Mamadou, so it automatically detects the type. Automatically, I'm gonna assume some things here, Mamadou. Do you mean that this is automatically detecting the type? I would assume. Is that okay? Yeah. So it's actually, this is like it's in the same line. Let's make this slightly different. It's a little bit harder to visualize, but I'm gonna mention it like this. So this is like this. So it's like I'm creating a new prime minister, and right away in the same line, it's still part of the same line, okay? Right away, I'm setting, okay, prime minister has a first name, so here's the first name. Oh, prime minister has a last name, here's the last name. If I put a comma here, look, actually, let me see. No, it doesn't show automatically. That's fine. So I can list every single public property, and I can set them right away, right here, from this curly braces syntax. Okay? It's like it's part of the same line. Okay? Great. Okay, again, if you have follow-up, please let me know. But this is the same as this. Well, let's put it this way. It will result in the same thing. Okay? We are just getting familiarized with a new syntax, a new way to put things together. Now, I'm going to comment this out because I don't want this to be hanging around here. I'm just going to keep it like this. So I'm going to add each prime minister to the list. Look, the second one, the third, the fourth, and the fifth. Okay? So added each one of them. I'm just going to keep these collapsed so it's a little bit better to visualize. Okay? Here we go. Okay, then what? We populated our list. Our list is there. Now we have 5 prime ministers in the list. But now I really want to add those prime ministers. Not I really want. I also want to add the last name of each one of the prime ministers to the list box. To this list box here. Okay, I need to add them. So I'm going to loop through my array, because now, sorry, not array, through my list. So I'm going to use the syntax here called for each. So this for each loop will go for each prime minister. I'm going to call it PM. It's just the local variable inside the loop. In prime ministers is the collection, is the list. Do this. Do what? This. go to the items of the list box and add the last name of the Prime Minister. So loops 5 times, adds 5 last names to the list box. Okay? And then we have this line here. Can anyone tell me what this line, this selected line, is doing? Anyone have any clue? Select index 0 in form. Is that in the form that it selects, Sina? This is the form? What is this? It's set in the selecting the list to empty. It means it runs. Okay, so first of all, to clarify, LST prime ministers is the list, is this control here, okay? And when I say select 0, which item is being selected from the list? Which item? Is that the last item? The first one will do. Yep, that's it. Why am I doing this? I'm going to show you why. The first one's in. Yes, that's correct. Why am I doing this? Let me comment this out and let me run. Let's see what will happen. Okay, so I'm going to run this. Okay, look. It ran. But at first, there's nothing selected. So it's not showing an image, it's not showing the name, it's not showing anything. Unless I click, then it will start showing. Because I don't want this behavior, I want the first item to be automatically selected by default. That's why I do this. I set the selected index to 0, to the first one. If I run this again, I should be able to. Here we go. The first item gets selected and the information from that item gets displayed as well. Okay? Okie dokie. Questions about this step, questions about the load, the form loads, anything comes to mind right here from this event. I'm gonna check Padlet as well. Okay, nothing going on there. Okay. Okay, that's fine. So let's move forward then. So here we have the load. It's loading the list. Now, this application is quite simple. I mean, it looks interesting, but it's very simple. Can anyone guess what is the next event that we have to code, that we have to program? Anyone? Just think about this. You have to always ask yourself, yeah, so, okay, so let me see a question there from Ederson. I did not get why you have prime minister and prime ministers. Okay, no problem. So let's have a look at the code there. So prime ministers is the collection, okay? So at some point, we need to load the list of prime ministers in this collection. Then the other parts of the codes can refer to this collection to get information about a particular prime minister. So prime ministers in plural is the private field that is actually a list of prime ministers. Okay, so this is the plural one. The other one, prime minister, what do you mean by prime minister? Okay, it seems that you got it, okay? Okay, perfect. So just moving on here. So let's go back to the design there, to the form. So Sina, yes. Mazir, yeah, show information. So we have to code what will happen when we click the different last names of the prime minister. It's list on click. That's a good, I would say, suggestion, Mazir. Actually, we have in the list, in the list box, we have a few different events. Actually, a lot of different events. Okay, let's see here. We have a click, but we also have, actually, here's what we're gonna do. We're gonna be using this event here called selected value change, because there might be times that, for instance, if you look at this code here that we put in our code, selected list index equals to 0, this item, this code here, I don't think that it would trigger the click event. Click event is when you get your mouse and you click there, okay? This type of change will not trigger a click event, but if we use this other event from the list, which is called onSelected value changed, then if I reset the selected index, this event gets triggered. Okay? So now I can tell you this, there are lots of similar events here. If you had used selected index changed, it would have worked as well, because usually when you do one, the other one happens as well. Okay, so either you can do it under selected index change, or you can do it under selected value change. Again, you could do on either one, but I just picked the second one here. If I go there to the code, let's have a look what this code is doing. By the way, does it make sense about the events? I mean, anyone has any questions? Again, I'm checking Padlet here. Okay, so let's have a look. Okay, so Professor, we created a list of objects. Well, remember, Sina, every single class comes from object. Okay, so no, in the end they are all objects, but our specific list is a list of prime ministers. Okay, prime minister. So I'm creating each item in my list. It's not a list of strings, it's not a list of integers, it's a list of prime ministers. Index 1 will have the first prime minister, index 0 will have the first prime minister, index 1 will have the second prime minister, and so on. Okay, again, follow up, Sina, if you have a question. Edgar, when you double click the event, you give it the name, right? Yes. So it happens automatically, Edgar. If I'm gonna give you an example here. I'm gonna go to the forum. I'm gonna go to the list of prime ministers here, the list box. Now, if I double click the click, look what happens. It creates automatically an event for us with the name of the control, in our case, LST prime ministers, underscore the event. Okay, so this is the standard way to name an event. The name of the control, underscore the name of the event. I don't know if that was the question, Edgar, but again, follow up if... Okay, great. Sina, but object of prime minister, okay. Okay, so, okay, Sina, I'm just trying to understand your point here. Okay, so, well, here's the thing. When we instantiate a class, we call that an object, okay? So every time that you call new something, we are creating a new object of that type, okay? Again, not sure if that's what you are asking. Yes, we create a list of prime ministers, a list of objects. Okay, so maybe this is it. we have created a list of objects of type Prime Minister. Make sense? Okay. Good. Awesome, awesome. Okay. So let's keep moving forward here. So let's look at our own value change. Let's look at that. And let's see what this is doing. Okay, so look, here's what we want to do. I'm gonna tell you what we want to do. We have the list of last names. Remember, there in the list box, we only have last names. That's the only thing that we have there. Now, I want to make sure, I want to be able to click in one of those last names and the corresponding Prime Minister should be loaded. Okay, the one that I select there should be loaded. Now, we have to think, okay, so where's the information of all Prime Ministers? Well, the information is in our list. Okay, what's the name of our list? Prime Ministers, plural. Okay, so I'm going to start by declaring a local Prime Minister. This is a Prime Minister that is local to this event. Why am I doing that? Because this guy here will be the one that will hold the Prime Minister information once we find the selected one in the list. So we're gonna loop through the list. We're gonna check, oh, we're gonna get the first Prime Minister. Does the first Prime Minister have the same last name as the selected one? Yes or no? If yes, I got it. I got the Prime Minister. Okay? So that's what we're doing here. We're going through a for each loop that we're saying for each Prime Minister, call it PM, in Prime Ministers, plural, Prime Ministers list, and then we check if the last name of this Prime Minister in the loop is the same, is equals to the selected one in the list box, and we get the selected one by using the selected item to string. So if there's a match in the last name that is selected and the one that I'm looping through, get this Prime Minister, get this one. Get this guy, because this is my guy. This is the guy that I selected. And then store it, at least temporarily, store it in our local Prime Minister object. Okay? Store it here. Oh, Ederson, why are we going to store this? Well, we're going to store that because now we're going to retrieve the first name. Last name we kind of had already, but first name, last name, party, and term. We need all the information. The information was in the list. We found the matching Prime Minister. Now we're going to display the information. Okay, questions here, but we have first name and last name, correct? Yes, we do, Modu, but here's the thing. We are making last name unique, so the last three Prime Ministers, they have unique last names. There's no repetition there. So when we find the correct last name, we load the entire Prime Minister, not just the last name, but the entire Prime Minister in our local object. Then we can use Prime Minister to access first name, last name, term, and party. Correct. Let me run the application here. Check it out. Look, we have the last names, Trudeau, Harper, Martin, Christian, and Campbell. Okay? That is why. So we use last name for that. Okay, so perfect. So we loop through, we find the matching one, we load the Prime Minister information inside our local Prime Minister, and then we can use the properties of our Prime Minister object to load the image location. Look, the picture box has a property called image location. Let's have a look at our images here. So check this out. our images, you see, look at their names. They are named by the last name of the prime minister. So we can say load Trudeau.jpg. That's what we're doing here. Load based on the prime minister last name plus JPEG. So we just set this up, and this alone, this simple line, loads the image in the UI, in that spot, okay? Then we get the label last name gets the first name plus space plus last name. The term gets the term of the prime minister, and the party gets the party property. Okay. That's about it. Questions, confusion? Give me some. Again, anyone stuck there? The code is there for you to download. Okay, so you have access to this code. Is already there for you. Mazir, so if the picture does not exist, it occurs an error or displays an empty box. To be honest, I don't know. Let's give it a try. I think I don't know. I think it will display an empty box. I think. Let's give it a try here. Let's just mess things up a little bit here. So let's say that I don't know, by accident we put A here. It's not gonna find this name, the image with this name. So let's give it a try. See, look at that. It doesn't give an error, but it shows this broken icon, which is what happens when it can't find the image. Okay, no problem, no problem. Okay, so I'm gonna just revert this back. But this is the thought process that you have to go through. You have to ask, which event should I use? Which event should I use? It's almost always about where should I put this code? And by where, we really mean when. When, what will happen that this event needs to be triggered. Edgar, okay, so where and how did we store the images? Okay, I just stored them in the bin folder, the debug folder. I don't want to put a path to them, so I just stored them in the same folder that the application gets compiled into. See here, we have the application. So just to make things easier, I didn't go with a full path. I'm storing the individual files inside the debug folder, which is the folder that the application gets compiled into. Okay, the exe gets created there. Okay, and so where and how? Well, how, again, I just stored the plain and simple images, the pictures. Okay, so those are simple JPEG pictures. Awesome, awesome. Okay, great. Let me see here. I think that's it about this exercise. When we come back from a 5 minutes break, we're going to start test-driven development, okay? So I'm going to give 5 minutes. We come back, we're going to start a new topic. See you in 5. No quiz today, okay? No quizzes. Quiz will be next week. Okay. Can you please just confirm that you can still hear me? Okay, thank you guys, thank you James, Matthew, Zir, Sina. Okay, great. So let's get things started here. Okay, so we're gonna be talking about a topic that is very important. Every structure says that every topic is important, isn't it? So this one is quite significant, let's put it this way, because actually, you know what? Let me step back for a second. I'm talking too much. I like to hear my voice too much, I think. What is your expectation about what you're gonna be talking about today? Any particular expectation? No idea. Sina, you have to have some idea. You know why? Because bonus 7 was about research being done around this topic. So again, give me give me some ideas, okay? Anyway, anything comes to mind? Again, I appreciate the honesty, Sina. Anybody else with any? I mean, if you hear this phrase, this word, test-driven development, okay, Mazir, test program before deploying, okay, along those lines, I get it. It's close to that. It's towards that direction. Yes, Modu, arrange, act, assert. Yes, I know you are answering the question there in the bonus. I get it. So we're gonna see what that really means today. We're gonna see what is arrange, act, and assert. Okay, so test-driven development is how you can create code that tests your code. Code to test your code. Code that you say, I'm giving you those values, and I'm expecting to get back that third value there. Is it really happening like that? So I'm going to repeat this. It's code that will automatically test your own code. It's almost like you are creating code that double checks what you have done to make sure that it's correct. You are coding to test your own code. It might be your own code, it might be somebody else's code, as you're gonna see a little bit more about that today, okay? Okay, so today my objective is to show you the requirements of how to put a test project together. I'm gonna do this by performing a walkthrough. I'm gonna go hands-on myself as I demonstrate how to do that. I'm gonna be creating a unit test project, and we're gonna be creating, in that project, we're gonna be creating a test class, and inside the test class, we're gonna be creating multiple test methods. Each step along the way, I'll be demonstrating here. We're gonna be building our solution. We're gonna be running our tests. You're gonna see there's a very, very neat interface built into Visual Studio that will help us, that will show us in a graphical way the problems in the issues that our code may have. We're gonna have some problems there. We're gonna fix those problems, and we're gonna be using unit testing to improve the performance, improving our codes. That's what we're gonna be doing today. Okay, so unit testing, it's important because you can catch problems before they catch you. That's really it. With unit testing, you're gonna create units of tests. By units, you can think of methods. Each method is a different unit there. So units of tests that will run it will kind of run simulations on your code to see if what you are hoping to get back from it, it's really what you are getting back from it. Now, we're gonna be building a very, very, very simple application, Windows-based, because I want us now to focus a little bit more on Windows development. So Windows-based, but very simple. It's a very simple calculator that will only do division, only divide two numbers. That's it, two integers. Our goal is not to make the application too complicated, but to cover how we're gonna start from scratch with a brand new test project. Okay. Before we get hands-on, though, this video here, it's a 2 minutes and 30 seconds video. I'm gonna give you about 3 minutes, just so you can have a look at this video. I will be playing it here, but you will not be able to listen to the video from my presentation. So I'm going to copy the link to the video on the chat, so you can access from the chat or from Padlet. I'm gonna put on both places. Okay, so please take 2.5 minutes to go through the video, and we will get back after that. Okay, I'm going to assume that you had a chance to watch the video, okay? And I'm gonna move forward here. So what I'll be doing now is I'll be opening Visual Studio so we can go through a brand new application using Visual Studio. Initially, it will be just a simple Windows application, but eventually we're gonna add a test project to that solution, okay? So to get this started, we're gonna go to File, New Project, and we're gonna, as I said, we're gonna create a very simple calculator. Creating a new project here, we're gonna create a Windows project. Sound problem again, okay? Is that generalized? Everybody is getting that, the same problem. Anyone else, can you please? Nope. So is it, it's all good? Now it's good? Not robotic, nor, it's good? Okay, great. So it might have been something temporarily. Okay, so as I was saying, when you're creating the project for the first time here, you will not be creating right away a test project, okay? You're gonna be creating a simple Windows Forms app.NET framework. The test project will come afterwards. Initially, just a Windows form. I'm gonna click next. I'm gonna name it calculator. Now, one thing that I would want to bring to your attention. By the way, if you want to do this as I do it here, you can do that in your own environment too. Okay? So one thing that I would urge you to do it is uncheck this box that says place solution and project in the same directory. And I'll show you in a second why. It's better if I show you in the file system. So again, make sure that you uncheck this box. In terms of framework, you can keep the latest one that you have available there for you. Okay, solution name, you can keep the same name. That's okay. But again, very important that you uncheck this one here, this box. And I'll show you why in a little bit. So let's click create. I'm going to show you why I unchecked that box. It's because of this. I'm going to the folder of the solution. I'm going to open the folder in File Explorer. Look what we have. We have the solution file and we have the project folder here. If we kept that box checked, this file would have been created inside of the same folder as the project. Then later, once we try to create the project, the test project, it would not create another folder in the same calculator folder. Let me summarize this. We uncheck that because now we're gonna have one solution project, one solution file with two projects. Each project will have its own folder, but both of them will be under this bigger solution. So far we have used one solution, one project. Now we're gonna use one solution, two projects. The first project is a Windows project. The second one is the test project that we're gonna use to test the Windows project. Okay? I get it, Mamadou. You get a slightly different interface. That's fine. It has more or less the same options. You're gonna get a Windows form application, and you're gonna see there. Actually, if I open 2017, let me open that quickly here. So you don't have that wizard there, I get it, but you have this. So file, new, project. Then here under Windows Desktop, you have Windows Forms app.NET Framework. This is what you're gonna be using. Now here is the same checkbox, creates directory for solution. So actually for this one here, for this one, you should keep it checked because in a way it's kind of the opposite as the other one. Okay, so keep this one checked. Okay, that's good. That's good. And I think it's selected by default. Okay, so keep this one checked so it creates the main folder for the solution and a subfolder for each project under that. Okay. So again, slightly different interface, but you're gonna get the same outcome. I'm gonna close this one here. I'm assuming that you are using the VM, correct? Got it. Okay. So I'm gonna go here to the application again. So let's do a few things. Let's name properly our form. No, let's call it let's say FRM calculator. Okay, so let's see what else. Now, as I said, we're gonna be doing a very simple application here, very simple calculator. We're gonna have a title as well. I'm not gonna change property by property here. I'm just gonna do a few. So text will be this one. You see the text there. Now I'm gonna copy the controls from another application to this one. Here we have. So very simple. We have a few labels here and a few text boxes. The text boxes are already named properly. We have txt numerator, txt denominator, btn divides. That's the button that we click that we're gonna divide one by the other. And then we have here the txt results. Okay. Again, nothing too fancy here. Just a few controls, labels, text boxes, and buttons. Okay. I named the ones that I'm gonna be using the most. I'll be using them in the code. Okay, so I named them properly. And we're gonna code the click of the button. Okay, so we're gonna go to the events, click. I think that it's already there. Let me have a look here. So Sina is asking for the code. I think it's already there. I'm just gonna double check that. Week 12. Here it is, calculator example Windows. So the code is already on Centennial under week 12. Code is all there. Okay, no problem. Okay, so here's the button, the divide button. Okay, now we're gonna do something a little bit different here. Instead of, I know it's a simple division, I get it. We could do that with one line of code, I get it. But the goal is to create a class that has a method that we're gonna check whether or not this method is working as expected, okay? So we're gonna create a class that I'm gonna call simple calculator, and it will have the divide, a method called divide there. So I'm gonna right click in the project, I'm gonna go to add class. Here is the name of our class, simple calculator. I'm gonna add, and from here I'm just gonna add a very simple method that I'm gonna call divide. So I'm gonna say public int divide. It's gonna accept two parameters. I'm gonna call them numerator, denominator, just for the sake of consistency here. Numerator, and another one called denominator. And we're just gonna return numerator divided by denominator. You might be asking, Edson, this is too basic. I mean, how come? Why we need to create a method just to do that? Again, I'm keeping the method in the application very simple because we need to focus on a major, a new topic for us, which is the test application that you're gonna be we're gonna be doing that in a second. So, very simple method, just divide the numerator by the denominator, okay? No matter what we put as the numerator and denominator, it will always return an integer, because if we divide two integers, it always returns another integer, okay? So it's gonna round things if we have decimal points, okay? So here's our method. Now I'm just gonna make this method even simpler, okay? I'm going to say that instead of being a dynamic method, by the way, this method here, it's the way it is right now, it would need an object of this type to be created, and I don't want to go to that trouble. I want to make this divide as a static method, okay? So I can call it directly from the class. So I can say static int divide, and now I'm gonna be able to say simple calculator dot divide, and I'm gonna get the value. I'm gonna get the return. What happened, Sina is asking, what will happen if the denominator is 0? Sina, hold on that thought, hold that. We're gonna handle that a little bit later today during our test scenarios, okay? Hold to that. I'm not gonna address that right away. So let's go to form here. Now, our button, we can say, we have to get the values of this. Yeah, an exception will happen, Edgar, that's fine. But we're gonna be using that as part of our test as well. Hold on to that thought there. So, we have to convert this number, this text number, and this one to integers so that we can use our method, okay? So we're gonna do this. We're gonna say, in our click, we're gonna say int numerator equals to, what's the name of this control here? Well, this one here is txt numerator. So I'm gonna say equals to txt numerator dot, which property am I gonna use to get the value that we typed in the text, in the txt numerator? What is the property? Anyone? Which property of the text box should I use to get the value that the user typed? Yes, text. That's a text. Okay, so great. I don't think that text box has a value, James. Okay, so we're gonna get the text, but we have to do something else here. What is it that we're missing? Yes. So we can use any method that converts a string to an integer. So we can say something like this: int parse. Okay. Convert, you can use convert, you can, yes, we can use convert or parse, okay? So I'm just gonna use int parse. I'm gonna do the same thing for the denominator. And here is the name of the control. So we get the numerator, the denominator, and then we call our methods. We're gonna say int result equals to the name of a class, which is simple calculator, dot divide. Remember, we made divide as static method, so we don't need an instance of simple calculator. We can just call simple calculator dot divide. First parameter, numerator. Second parameter, denominator. And then we get the results. With the results, we're gonna show that in the txt result dot text equals to result. Now let's convert this to a string. I can say to string, and then we have it. Okay, so let's see this in action. I'm gonna run it. Okay, and here we have, I set those values by default. So if I click divide, I get number. If I change it here, I get the correct value. If I change it here, again, working fine. Okay, all good, all nice. But how can we write a test case that can prove to us that this method is really working? Again, I'm going to repeat this once more for a third time. I know that this is very simple. We cannot go too wrong here. However, we have to keep in mind that the technique that you're going to be using now, you're going to be able to use that for any methods or any situations as complex as they may come, for anything, okay? For any method that needs to return a value, we're going to be using this strategy to apply to that. Yes, I know we are using to test something very simple, but what I want you to get out of here today is the strategy, okay? Don't focus on how easy this is, but the strategy that you're going to be put in place to check whether or not divide is working the way we expect it to work, okay? So we're going to start by adding a second project to our solution. Right now, our solution has only one project. The solution name is called calculator. The project name is called calculator as well. We're going to create a second project under the same solution to store so that we can create our test application, the application that will test the calculator for us, okay? So for that to happen, we're going to have to right click the solution entry here in the tree view. Now let me just go back to the file manager, sorry, to the Windows Explorer. Look, right now we have the solution file and we have the project here. When I create this test project, we're gonna have a second folder here as well. Okay, just want to bring that up to bring that to your attention so you can double check later. So from here, I'm gonna right click the solution. I'm gonna go to add new project. Now we're gonna find the test project that we need to add to our solution. The test project template, we have to call it, we have to search for unit test project.net. Okay, because there are many different templates here and it's very easy to pick the wrong one. Okay, so type this in. You should be able to find a C# template called unit test project.NET framework. This one uses MS Test. Look here. It's very easy to get confused and select one of the .NET Core ones. We're not going to use that .NET Core in this course, okay? So you have to select .NET Framework, but you should not select VB because we're studying C#. So again, the only one that is the correct option for us is Unit Test Project.NET Framework. That's the one, okay? So again, you have to type this in. If you are using 2017 module, you should be able to see this in the list of templates on 2017 there in your case. Perfect. Okay, so again, you may even want to copy this name and keep that so you can find that easily. Unit test project.net. I'm gonna click next. Now, the project name. I'm gonna give you a recommendation here. This is not set in stone. It's just my recommendation. The recommendation for the project name should be the name of the project that you're going to be testing the methods from. So in our case, calculator plus the keyword tests. Calculator tests. Okay? If it's a different name, tests. Just to indicate that this is the tests project for the calculator project. Okay? Don't change the location. It's going to create another folder under the calculator solution. Framework, you can keep the latest one that you have there available in your environment. And then we click create. Okay? Create. Okay, give it a second. Awesome. So look, now we have two projects. Let's have a look at Windows Explorer. Look, we have the other one here, calculator test, the new one. Calculator is the original one. And then we have packages. Packages is a folder that stores additional packages necessary for those projects to work. Right now, this package has the MS Test framework, okay? Because it's being used by the calculator tests, okay? So, second project here, we're gonna be first renaming our unit test1 class, okay? So we have the file name here, we have the class name here, we're gonna rename them. We're gonna rename them to something closer to the class that we're going to be testing. So general rule of thumb is that for each class that you're going to be testing, have a different class in your test project. Okay, so because you're going to be testing the divide methods of the simple calculator, I'm going to call our class, our test class, as simple calculator tests. Okay, guess what? Tests. So test at the end. So keep the same name as the class that you are testing plus the keyword tests. Look at this. When you hit enter as you are renaming, it's gonna ask if you want to rename the class as well. You can confirm this. So just to recap, I clicked a second time in the class, or I can just say, I can right click and I can say rename. And I can put the other name, I can hit enter again to confirm, and it will rename not only the file, but the class name as well. Okay? So both of them. Any questions so far? It doesn't have method for you. Does it have, Sina, does it have this test class at the top here? Okay, so most likely you have created the wrong template. You have used the wrong template. Are you sure that you have used the test template in Visual Studio? You may have selected a different one. Okay, you may want to double check that, because again, if you don't select the test template, you download it from Centennial. Okay, so you downloaded, I'm assuming, from this code here on Centennial. Okay, so I'm gonna try to download it. I just want to see if by any chance, I mean, I may have uploaded the wrong one, so, or an incomplete one. So let me just have a quick look at that. Okay, calculator test, simple calculator test. It's all there. See that? It's all there. Calculator tests, simple calculator test. Okay, so the code is there. Again, I'm not sure what you're looking at, but if I were you, I'll try to download it again. Okay, because it's there. Now, it's already finished there, okay? So we are going step by step here. What you see is the final result already, okay? Again, let me know if you have any follow-ups there, but the code is correct there. Okay, so go back here. Okay, great. Okay, so here's where we are. We have just renamed the test class. Now, when you look at this, what is different here as compared to what you are used to see in a regular class? Okay, what do you see different here? Give me some feedback there. No main. Okay, no main. Yeah, you're right, Mabudu. Let's focus for a second in this class alone that I have selected. When you look at a regular class that you are used to create, do you see anything different in a regular class as compared to this class? Yes, James, so correct. So we have this test class in this test method, okay? This is called an annotation. You're gonna see this either as annotation or as, there's another term that is used as well. It's escaping my memory right now, but so you're gonna see this annotation here. This annotation is used to flag this class as a test class. It's not a regular class, it's a test class, it's a special class. And this is not a regular method, this is a test method. So Visual Studio used those annotations to understand, oh, this is a test class and this is a test method, okay? So this is used by Visual Studio. I'm gonna show more of that a little bit later, but we need the annotations to flag that this is a test class and this is a test method, okay? Great. Now what? Now what? Let me start by saying this. There are a few things that are particular to a test method. 3 things. Again, if I were you, I would write them down. I would keep there because this is a good one for a quiz. By the way, we're gonna have a quiz next week that will cover Windows development and test-driven development, the GUI and test-driven development, the class of today and last week's as well, okay? So again, this is a good one to be in a quiz. 3 things that are required for a test method. 1, it needs to be public. 2, it needs to be void. It cannot return a type. It cannot return a value. The return type has to be void. Okay? In the third one, there are no arguments for the method. Public, void, no arguments. The 3 requirements of a test method. Okay? It has to fit those 3 criteria, those 3 conditions: public, void, and no arguments. Okay, now what? Now we're gonna write our first test method. Okay, we're gonna start by renaming the test method that we have called here test method 1. You're gonna rename that. We're gonna apply a general rule on how we will name our test methods. Our test method names will have 3 parts. The first one, and this is just a general recommendation here. The first one is, it should tell me which methods we are testing here. We're gonna be testing the divide. We're gonna be saying, hey, is dividing work as it should? Is it return the correct value? So we're going to be testing the divide method. So the first part of our name will be divide. The next part we're going to separate by an underline. And the second part will represent the input values that we are giving to our tests. A test will have, sorry, just resize things here. So I have to somehow give an idea of what are the values that I'm providing to this test. And you're going to see that in a second. I'm going to call this, it could be numbers, integers, it could be anything like that. I'm just naming it. Could be regular integers, something like regular numbers, anything like that would do it. And I'll show you which values are those in a second. The third aspect, the third part in our method name is, what do we expect as the result of this test? Well, I expect a division to happen, okay? So there are certain cases that we expect, you know what, we may expect even an error sometimes, but not in our first test. Our first test, we expect a correct division. So we expect a division to happen, okay? So the name of the method, an indication of what are the values that I'm giving to the method, and what is the output that I expect. Not a numeric output, but what is the result that I expect from this operation. I expect a division to happen, okay? Again, this is a bit blurry. As you get used to name your methods, you're gonna get a better hang of it, and as we progress as well. But now we're gonna start by doing what you have answered on bonus 7. Remember, you said something about, someone said something about the 3 segments that we have to create in our method, our test method. What are they? Can anyone tell me there on the chat? 3 A's, yes, Sina. AAA battery. What are the A's? Arrange, act, and assert. Yes. So let's create the first one here. Arrange. So by arrange, what it means is that what are the values that I'm organizing to provide to the method that I'm testing. So I need to come up with them. I need to think, okay, what is it that, first of all, what are the arguments that my method is expecting? So let's have a look there. So we have two arguments, numerator and denominator. So we're gonna arrange initially two values. We're gonna say int, I can even keep the same names as they have in the parameters. Numerator, int denominator. So I'm gonna try the sunny situation here, the sunny case, which is a case that all works fine, all should work fine. I'm gonna try a numerator, let's say 20. So numerator equals to 20. Denominator equals to, let's say 10. Now, I'll ask you, what is the expected result? I expect 2. Okay, so I'm arranging the inputs and the outputs. So I expect I'm giving it 20, 10, and I expect back 2. Okay, so we have arranged the values. We're gonna act. Now, think about this. What does it mean, act? What is it that we're gonna do with this act section? We're gonna perform the action. Yes, although we're gonna perform the action. Okay? So we're gonna call the method there. Which methods? This one here. Divide. Okay? So let's do the same thing that we did when we call the result here. Okay? Here we're gonna call not result, but we're gonna say actual. This is the actual value. And we're gonna call it simple calculator, divide, numerator, denominator. Those are the two parameters. Now, we have a problem. Houston, we have a problem. Simple calculator cannot be found. What's going on? Who can tell me how to fix this? Simple calculator cannot be found. How can I fix that? Inheritance, okay. Okay, so we're not gonna be creating here descendants, children of simple calculator, okay? We need to use it straight as it is, okay? So, Mazir, namespace, Sina, public, although inheritance. So again, we're not going to be using inheritance, but let's have a look at first what Sina is suggesting there. So let's go to our simple calculator. Look at this. Right now, this class, what is the accessibility modifier that is being used right now? Because we don't have anyone. Is it right now, right the way it is right now? What is it here? Although, yes, internal. So by default, this class is internal. See, we saw internal way back then, actually a few weeks ago. And I said, internal means it's only visible to the current project. Okay, so right now, simple calculator can only be seen by the calculator project, not outside, because it's internal. I have to set it to public. Okay, so instead of internal, it's now public. Okay, let's see how it goes. Okay, we still have a problem. We still have an issue here. What now? What should we do? What should we try next in addition to making it public? Maybe we have here, Mazir, you said namespace. That's towards that direction. Yes, that's correct. We have to add the namespace. But let's look. Let's try this. Using, what is the namespace of this one here? Of this project, of things here. You see? The namespace is calculator. Okay? So, if I try using calculator, it cannot find the namespace. So, what's the issue here? What's the deal? Anyone? It cannot find the namespace. The namespace is here. It's correct name, but cannot find that. Why is that? Any guesses? Anyone would take a stab at that? Mazir is Sina. Mazir is teasing you. Okay, James, namespace needs also to be public. Okay, so namespaces, they don't have an access modifier, James. So we don't need to say that about the namespace, okay? But here's the problem. I'm gonna give you some clues here. Do you think that even though calculator test and calculator, they are under the same solution, do you think that they can see each other? They cannot. They cannot see each other. They are under the same solution, but just because of that, it doesn't mean that we can see each other. They cannot. Yes, although they are different projects. Think of them as two different entities there. Yes, they are under the same solution. Yes, they are under the same folder, top level folder, but they don't know about each other. They are not aware of each other. I have to make them aware of each other. More specifically, I have to make calculator tests aware of calculator, because calculator test is using a class and a method of calculator. Okay, so to do that, I have to add a reference from calculator test. I have to say I want to create a reference to calculator project. So I'm gonna right click under references of calculator. So again, calculator test is the one that has to reach out and be able to see calculator, what's inside calculator. Okay, that's why I'm gonna add a reference to calculator tests linking back to calculator. So under references here, I'm gonna right click, I'm gonna go to add reference. Here we have many options. One of them is projects. I'm gonna click in solution, and I'm gonna click in the checkbox that says calculator. This is the name of the other project in the same solution. Okay, and I'm gonna say okay. Now look at this. Calculator became part of the references of calculator tests, and now we can see calculator namespace, and because of that, calculator, simple calculator is also available. Okay? Anyone got stuck or got confused with this? Quick recap of the steps. I'm going to add a reference to the calculator project from calculator tests. I'm going to go to the references. I'm going to right click. I'm gonna go to add reference and then solution and then just click the calculator. Click OK and you made the reference. That's it. Confusions? Questions? Awesome, Mazir. That's really it. And we have used it before. Remember, not from a project to a project, but we have used it before. In which context? Who can tell me? Who remembers? Where did we use references before? Yes, James, Azir, yep. JSON. When we were using JSON, we had to add a reference, but not a reference to another project, but a reference to an external library. Okay, great. So how about we finish this up? So next section here, we have the assert section. And in the assert section, we have a class that we're going to be using. This class has a lot of methods to be able to identify, to be able to help us with our tests. The class, guess what? It's called assert as well. It has a bunch of static methods that we're going to be using to check things. If it's true, if it's false, if it fails, if it's equal, if it's not null. In our case, we're going to test dots are equal. Which ones? If the expected value is equal to the actual value. Okay? So this is what will tell Visual Studio that this test run successfully, yes or no. This is the one. This is the line. Okay? Now, with this done, we will have to activate the testing environment that is available for us by Visual Studio. So we're going to go to Test menu and we're going to click on Test Explorer. If it takes up the entire space, you may want to move it to the sides. I usually like to keep it on the sides. So now we have Toolbox and Test Explorer, okay? So if you have a look at your Test Explorer, you're gonna expand, 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 and then you're gonna get to the test. Look, we have here the solution name, the project name, the class name, and the method name. Okay, so we have this entire hierarchy. For now, we just have one class, one test class, and one test method. You're gonna be creating more test methods, but for now, this is what we have. So, look, the exclamation mark is telling you that this test has not run yet. We have not tried to run the test yet. How about we test this? How about we give this a try? So you can go and you can just click on the play, on the run button. It's gonna compile the code. It's doing that. And let's see. Look, it's running and we have a green checkbox, okay? A green check. It means that it succeeded. The test worked. The expected result matched the actual result. It tells you even how long it took for the test to run, okay? Great. Now you may be asking, now what? Okay, Sina, how to open Test Explorer? Okay, no problem. So you have the test menu and then you go to Test Explorer. There is a shortcut, Ctrl+ET. I'll try to memorize that. So test and then Test Explorer. Okay, so again, we run, it succeeded, but let's make a mistake. Let's do a mistake here. Anyone can give me a suggestion on how we could insert a mistake in this test? Here, I guess that you guys mean here, correct? In the expected. Okay, so let me tell you this. Got it. But let me tell you this. The arrange section in the test case, this has to be correct. You should not mess around here. Because, look, you are making a mistake inside your test. Actually, the test is assumed to be correct. The test is correct. What we are testing is what can be going wrong. Okay? So you have to make sure that your test arguments is correct. So you should think about, okay, I'm testing this method here. If I want to see a scenario where this method is incorrect, I should go to the method and mess it around a little bit. Because you have to assume that your arrangement is correct. Don't mess with that. Because that has to be arranged correctly. If you put a 2 here, a 3, you are screwing things up big time. Because you are saying, you are looking at this, you're saying, okay, if I divide 20 by 10, it's going to be 3. 3. Really? We know that it's not. So the arranged variables, they need to be precise. This is what we're gonna be testing divide. Now, we can go back to divide. How about we mess things up here? Who could give me a suggestion on how to mess things up here? Just a little bit, something that might be, I don't know, a normal mistake of someone, you know? I can think about a few here. That's it. Let's swap them up. Let's do this. Okay? So now we did that. How about we test again? Let's run the test again. Here we go. Still running. And look, now we have a problem. The test failed. And it says, message, assert R equal failed. Expected was 2, but actual was 0. Okay? So it tells exactly what happened there. It was expecting 2, but it really got a 0. And it failed. Now, knowing that, we can visit our test method. We can see what was the method that gave us the problem, and we can go there and fix it. Now, for the fourth time, we have a very simple application here. Imagine that how effective this is in a bigger application, that we have many people working, that someone made a change, and now with a simple click of a button, we can run a general application test, and it's gonna test everything again for us, and it's gonna tell us whether or not that minor change that someone did, if that had any effect anywhere else in the code. Okay? So that's how we use this. Okay? So simple text, simple calculator here, divide. And then we can just fix this. We can rerun. And we can see the result. Run this again. And now it's all good. So handy dandy. Okay. Questions, comments, suggestions, anything? Okay, does it matter, question here, does it matter if we reference the first class to the second or the second to the first? Yes, it does. Although it does, because here's the thing. Let's look at our project here. What is happening? Let's think about this. I'm using a method, simple calculator, inside our second project. So this method belongs to the first project. Okay? So I want calculator tests to have access to the first project, not the opposite. This project here, calculator, it doesn't care about what is inside of calculator test. Calculator test has nothing that is of interest to calculator. So the project that wants to get a method from the other project is the one that needs to refer to. Okay? Again, calculator, the first project, doesn't care about any methods in calculator tests. It doesn't have any interest on calculator tests. The opposite is the one that does. Calculator test is the one that wants to grab a class and a method from calculator. Did it make sense? Awesome. Okay, so how do we change cancel an existing reference? Well, you can go back there to your references. Actually, I don't think you need that. You can just go here, right click and remove. Okay, so you see here under references, you see calculator, you can right click and you can just remove it. Okay, in case you don't need that anymore. Or you can just click and delete. Great. Okay, so we're gonna do a few things after our intermission. One, we're gonna do an ear pod to recap some of the things that we have seen so far. After that, there are two more methods that I need to implement here. After that, we're gonna have another ear pod, and then we're gonna have an exercise. So that will be done during our second half. We're gonna have a break now, grab something to eat, grab some water, 15 minutes. We're gonna be back in 15, okay? So again, take a break, 15 we will be back.